Okay, so today we're going to do a midterm exam to review. So let's go to the next slide, Benjamin. Okay, yeah, so we're going to go over the solutions to midterm exam 2. We probably won't have time to go over anything, which is what everything, which is what I learned from the first lab. So maybe we'll try to go over section E first, and then once we've done that, we'll go over whatever questions that you all want to go over. And then I will spend the last few minutes talking about corrections and how you can earn points back. So yeah, we'll start from section E, and then Benjamin will do all the review and answer any of your questions. Okay. Oh, and then I will give you your exams back. Who hasn't gotten theirs back? Okay. I don't know where to let me switch. Okay. Okay, sorry, I meant to ask. Cindy, did you hear your exam? No, you can go. You can switch.
Okay, so hey guys. So today we'll be we'll be reviewing our midterms. And we'll start with this question. So can anyone just walk me through the thought process to solve this question? Okay. Good. Okay.
So this is a game, first of all. So the user must create words of length, at least 4. That first sentence already gives us a baseline of how long the letter must be, at least. So perhaps we can already have a sense that one of our conditions would be that if the user doesn't give a guess that's up to 4 letters in the word, that's the return false, or whatever. From the given 7 letters stored in a list named letters, and one of those letters stored in a variable named required letter is specified to be required in the user's guess words. That's another point of condition. So if the word, I guess we have it in mind that if the word that the user guesses has no letters from the required letters, then it's also invalid.
Sorry. So I'll just go over the initial question. The question says we are looking for a word of length 4 from given 7 letters, at least length 4. So that tells you, like he said, that tells you that it must have at least 4 letters. So the moment you see you are given a word that has less than 4 letters, you know you could eliminate that. So in this kind of situation, you can see there are kind of already base cases that you can use to know if a word is supposed to, if it's a valid guess at all. So first of all, it says the word must be at least 4 letters. So if it's less than 4, we don't care if it's in the required, if it contains the required letters, but we don't care if it's among, let's see, we don't care if it's in letters, or we don't care if it contains required letter. We just eliminate it because we want it to be at least 4. And also, like it said, after checking that, you can also check that it contains the required letter. Now, if a word is greater than, has a length greater than 4 or equal to 4, okay, if a word has a length that is greater than 4 or equal to 4, that's cool. That means it can be a potential guess. But then it also says that one of those letters are stored in a variable named required letters. So that means you must find the required letter. It says one of those letters, you must find the required letter in the guess we are given. So that's another base case for you to take note of. And then it says, note that letters can be used more than once. If the word has already been guessed, the guess is considered invalid. It says, write the function is invalid word that takes in as argument the user's guess initially, and then letters, which is the total, the different amount of letters that you can form a word with, and then, and then required letter, that's a single letter among that must be in your guess, the single letter that must be in your guess, and also a list of previously guessed words stored in a list used guesses. And like the question says, if the moment you have a guess and it's already in the used guesses, then you should invalid that you should return false. Yeah. So we should also assume that everything is capital letter, so we don't need to be case sensitive. Yeah. Does anyone want to like give me like with the explanation of the question, how would you approach this? How would you approach this? You already started, like you already broke down the question, but how would you approach this? Or how did you approach it? And then we can like build upon that. How did you approach it? And yeah. Even if it's a wrong way you approach it, then we can like see your point of view and then we can talk about that. Yeah.
So first we will check for the length of the string, and if it's less than 4, we automatically return false because it must be at least 4 in length. Then we go through every character in the guess and see if the required letter is there or not. If the required letter is not in the guess, then we return false. And finally, we check if all the letters are in the given list, and if one of them does not exist, we return false, otherwise we return the list is true.
So yeah, that's very good. So he said we must first check that it's greater than or equal to 4. That's the first case. And then he said we should go through the word and see if it has the required letter. But we don't need to use an extra folder. We just use the in operator. Remember, so we could just decide if this required letter is in our guess, then we can like, I mean if it's not in our guess, right, then we can already eliminate it because the required letter needs to be in our guess. And then the last situation, I don't think you mentioned that, but you need to check if the word is in the used guesses. Yeah, so because the moment it's already in the used guesses, we don't want to guess something twice. Since it's already in the used guesses, we can eliminate it. And finally, you said we should go over it to ensure that every letter there is in the letters variable given to us. Okay. So yeah, like you said, we already explained the solution. So we define our function, and now when we are grading, I noticed that when we're grading, I noticed that some people decide to use like different variable names. I mean, it's fine in Python, you could use any variable name, but for the purpose of the exam, try to stick with the variable name given to you, because that could like make you lose some points. So for example, required letters, I saw some people like changing it to just rect letters like REQ underscore letters, so that will make you lose some points too. So you want to take note of that on future exams because it shows that you pay attention to details if you use required letters instead of rect letters. So like we said, our first base case should be to check that length of guess is not less than 4. If it's less than 4, then return false. And then also, like I said, we also check that guesses and use guesses. We just use the in operator to make our code. It gives us better styling because we could just use the in operator rather than looping through our users' guess. Or yeah, rather than looping through. For the third one, the third test case where it says if required letter is not in guess. So we could just use the in operator rather than looking through our guess and checking if the required letter is in it. And then it says if guess is in used guesses. If guess is already in used guesses, we know we can't guess that word again. And then we eliminate that. And then after that, once we are done with handling all the false situations, we could still have one more false situation. And the false situation is if we go through the word that has a length of 4 or more, and then we find a character or a letter that isn't in the letter variable, that isn't in the potential letters we can use, then we also return false. Then once all of these test cases are passed, we can return true. So does anyone have any question on this? If you feel like there was a particular way you viewed the question and it affected you being able to solve it, you can also like share with us and then we can kind of correct that. Okay. Okay, so we'll move on to the next question. Yeah. So I'll just read the question and then, as usual, someone will talk about their solution. So it says we should write a function named key in values that takes a dictionary as a parameter that has strings as keys and a list of strings as values. Now, the problem we're trying to solve is the function should return true if any of the keys in the dictionary are also included as an item in any of the values in the dictionary, and then we should return false otherwise. Who can explain this question? Even before describing a solution, can you explain what this question wants us to do? Anyone? Anyone else? Interesting. Yes. Okay.
So I would say if can loop it twice for each key. And
Oh yeah, so I'm just trying, like, can you explain the question first? What does the question want us to do? Because you need to understand the question before implementation. So can you just explain what this question is saying, like, in a very plain English?
Yeah, there is a function that has two parameters, one dictionary and a list. Dictionary that has strings as the key and lists as its values. So we have to return true in case that the values of any of the keys is a key of the dictionary, and return false if it does not satisfy that condition.
Thank you. So here's what it said. We are going to try to check, what we are trying to do is we are trying to check that among the keys of the dictionary, you can find one of those keys as a value also in the values of the keys. If that makes sense. So we are trying to check that if, for example, A is a key in the dictionary, can we also see A as a value in any of the lists of the dictionary? So who wants to walk me, like, as when you think now, we've already explained it basically, but the implementation, how would you implement this? Okay.
So I'll explain how I did it, but not exactly.
Okay, yeah, for sure.
So we conveniently have an in operator which checks if value is in the given list. But here we have to check for 4 lists. I mean, the high should be in, can be in either of the 4 lists, and it would still need to return true. So how I thought about it is, let's just combine all 4 strings, all 4 lists together, and then use the in operator. That's how I did.
Okay, so what you did was you looked through the dictionary,
Yeah.
and then you kind of extended.
Yeah, extended the list.
And then found, yeah, that works too. So, but then, okay, so how do you check? How do you get the keys to see if it's in the dictionary? What do you do?
So I first used one for loop to append all of
Okay,
the
to get a
values
list.
to one
Okay.
single list, and then use another for loop to look through the keys and check like if the key is in the big list, then return true.
Okay, so that's also a good solution. So what he did was, what we are trying to do in this question, we are trying to check that we can find one of the keys as a value. So what he did was, he said he kind of went through the lists, created he went through the dictionary and created an even bigger. Sorry, he created an even bigger list, a very big one. He kind of appended each value we could find there. And then by doing that, we'll have something like A, B, C, D, E, F, G, H, I from the example. Alright? And then after using one for loop to get his very big list, then use another for loop to loop through the keys and check if he could find it in his new list. So yeah, that's a very good solution too as well. And that works.
Okay, I just want to pause really quick. I want you all to make sure that you're paying attention to Benjamin. And I know that some of you might be doing other stuff on your laptops and you think you already got this question, you get it, and you're not paying attention. But if you didn't get this question, I know a lot of you didn't, and a lot of you missed some points. The way that you can earn points back is to be able to vocalize back to Benjamin or other TAs that you really understand how to solve this problem, so that the next time you see something like it, you can solve it. So really, you should use this time because it's yours. So ask questions, or say you don't understand something, or stop him or ask about something. Because otherwise, if you don't advocate for yourself, if you don't stop and ask right questions, nobody's going to check in on you and say, okay, do you understand it? So I really want you to try to make sure that you're understanding everything. And so if you don't, raise your hand and stop him and ask, okay? Because I know a lot of you didn't get this question. So try to pay attention, try to really be engaged and be present. Because if you're not, then why are we standing up here helping you all, right? Okay, so again, if you have a question, ask, because I know a lot of you don't get it. So don't be afraid to just ask and speak up, because the people that are consistently doing it, I've seen you do it all the time. But I want to hear other people that haven't been asking questions actually try to use us and just ask, right? And speak up and say something. Okay, Goswell, you don't have your exam, do you? Let me give you yours.
And also, if there was like a particular mistake you made in the exams, and or there was a particular thing you realized you didn't get a 12, and you're wondering why you didn't get a 12, you could also like bring that up, and then we would show you the correction as to why you didn't get 12 on the question. So yeah, so there are really minor mistakes you could make in this. But yeah, let's see. The easiest way we'll be able to do this is, first of all, by looping through every value. So first of all, we are using a for loop to loop through every dictionary.values will give you a list. So since we are picking every list that we have in the dictionary, and every list is every value of each key in the dictionary. So the moment we pick the first list, for example, let's use dictionary 1. So when we pick the first list, we then look through the items of the first list. That we said for value lists in dictionary.values. That means we are trying to get every item, we are trying to get every value in the dictionary. And every value in the dictionary is a list. And then we are trying to pick each list now. So we are saying for value list in dictionary.values. And then we are saying for value in value list. Now what for value in value list means is for every character in the value list, for every character in the value of each key of the value. So we are picking A, for example, first. We are saying for every character, for every character in the first list we have. So we are picking A. We are saying if A is in the dictionary. Now when you use the in operator for a dictionary, when you are trying to check if something is in the dictionary, automatically Python is trying to check if it is among the keys of the dictionary. So if we pick A and we are saying if A is in the dictionary, we are trying to say if A is a key in the dictionary. And then that solves our problem because we are trying to check if there is a value in the dictionary that is also a key. So we're already saying if A is in the dictionary, then we return true because that means we've seen at least one of them that is a value and also a key. And then if we do this for every item in the dictionary and we can't find one that is also a key in the dictionary, all we need to do is just return false. It's that simple. So is there anyone that made some slight mistakes? You could also share it with the class so like people could learn from it. I mean it might be very minor, but it could also help people. So yeah.
I'm not sure if I used it because I'm not understand. But is it possible to like take out all the values and put them in another list and then check through that list?
Okay, yeah. So that was his solution as well. He said he went through the dictionary and then created another list, like you said, and kept on kept on extending, right? Kept on extending the new list he created. And then after doing that, he looked through the keys of the dictionary. For example, maybe for key in the dictionary, and then you keep checking if the key is in the new list you created. So that was also a good solution as well. Yeah.
So, can we use the cumulative patterns for these type of questions? Because I get confused on on some problems that might be solved with accumulative patterns, but instead of when I try to solve them, it becomes it does not make sense. So in which type of questions should we use them? In dictionaries or
I'm sorry, I didn't get your question.
it's I want to ask, accumulative patterns can be used to solve these type of problems, right?
Okay.
And should we use them to solve this? Because I saw something like you have not used accumulative pattern, right? Because that can be generalized to solve that type of questions.
So you mean by like accumulating the
Like, I'm just
the
talking
values?
as a general sense, not in this type, not in
I mean, for the most part, I'll say for this course, I guess the only time when, except if we are trying to deal with a very, I'll say, optimal space complexity. But for this class, we are not trying to do that. So you could use, if you feel like a solution works for you in this class, I guess you should just use it. But sometimes it just means that you, so far you can understand your solution and it works, I'll say you should use it. So you shouldn't try to eliminate some methods, so to say. Yeah, that's what I'll just tell you. So, I mean, I think your question is, could we always use accumulative patterns like in every question? If it actually works for it, then use it. Yeah. So yeah, does anyone have any question or anything else you want to share?
Is there a more efficient way to do this?
Good question. Okay, let me see. I would say the more efficient way to do this. So now, what do you think will be the? Okay, should we go into time complexity? Okay, but yeah, if it's about the time complexity of this will be we are going through every value in the dictionaries, every of the values in the dictionary, and then we are going through the length of that as well. So I would say that would be like O of m times n, where m is the length of the dictionary, and then n is the length of every list there. So that's not a very good time complexity anyway, but one thing we could do should be the one he said. So you could just go through everything once. You could try going through everything once, and then extending. Well, if you extend, yeah, I still say, yeah. I guess this will just, yeah. I think the best time complexity. This is just fine. Yeah, this is just fine. Because by the time you extend as well, you also have like a time complexity that is not so good. So yeah. Yeah. Okay. So yeah, I guess the best time complexity for this would be O of m. Yeah, that's very good. Yeah. So any other questions or anything you want to share or contribute?
It's the E1 question.
The E1 question. Okay.
Yeah, since it says that the user must create words with at least 4 from the given 7 letters.
Yeah.
How I thought about it is that if there are letters more than 4, it can have extra letters that are not from the list, and it is still referred to as long as it has the 4 letters.
So there's a. Sorry. So there's a list called letters, and what's the characters in the list called letters are the only characters you want to see in your guess word. So you're saying it could have like, for example, 4 characters from the letters, and then there'll be one that is not in letters, but it's greater than, since it's already greater than 4, right? That's what you're saying?
No, it has at least 4 letters from the letters, and it has extra letters that are not.
So it's not just about having at least 4 letters from our list letters. It's about having a string that every of the letters are in these letters and is also greater than 4.
That fourth example is
What?
fourth example is that question.
Okay.
Because it uses D, which is not in the list, that's why it becomes false.
But the 4th example,
Okay. Oh yeah, that's what I'm saying. Yeah, okay. Are you trying to argue with me?
No, I'm helping you.
Yeah, exactly. So like, yeah, agree with me, right? Okay. So I'm trying to say, like I said, I'm saying, you see the 4th example, it says tilde,
yeah.
and then you can find T in the letters variable. You could also find I, you could find L, you could find the A too, but you can't find D. So we return false.
So for that, I thought that the 4 letters are excluding the required letters.
Okay. So the required letter is T, right? We can find T in tilde, which is fine. And then that particular test case, that particular edge case is solved. We can agree that it's true. We can find the required letter. And then we also check, can we, when we go through our guess, can we be sure that every letter in our guess is also in the list of letters that we can use to build our guess? So we have tilde, for example. Now we are going to go through tilde and ensure that every letter in tilde is also in our variable letters. So we are going through tilde. We first get to T. T is in our variable letters, so that works. We get to I. I is in our variable letters, so that works. We get to L. L is in our variable letters, so that works. But then we get to D. D isn't in the variable letters, so that shouldn't work. You don't get that? So anything else?
Okay, so when I did it, I checked for if the guess was in the use guess first, which I think is fine. But what I did was I did a double equal instead of in. Do you know why that's particularly wrong? 'Cause I just didn't think about it.
Okay, what was your complete statement?
I just did if guess is double equal to use guess.
Oh, okay. Okay, so our used guess is a list. And then our guess is a string. So yeah,
Okay,
it
good.
won't,
Thank you.
yeah, sure.
Could we use guess to be a list of more guesses?
Yeah, for sure. We a lot, like, we have a lot. Yeah. So that's the whole point. I would say in a real life situation, the moment you guess, you save it into you guess. So in a situation where someone, maybe you come another time to like take a guess, you're not able to guess what you just previously guessed, something like that. Yeah. So is that fine? Any other? Okay. So yeah, question 3. It says write a function named best movie that takes in a 2D list as a parameter. Each row inside of the 2D list represents a movie and follows the formats: movie title, movie year, director, actors, and rating. So it's sure that every item in this 2D list will follow this format, so you don't need to worry about that. And then it says the function should return the title of the movie that has the highest rating. If multiple movies have the same rating, choose the most recent movie. And it says it is guaranteed that if there are multiple movies sharing the highest rating, they will not be from the same year. So can anyone like just explain this question? Just explain it without thinking about how to implement it, but yeah, just explain it.
So you're just looking for the movie that has the highest rating. So that's in the last one. You could see the like floating numbers, those are the ratings, and you have to check which has the highest one. And after you find the movie with the highest rating, you have to find if there are multiple ones. And if that's the case, you gotta look like that came out the latest. So which was like out in the recent years. And for this case, like the highest rating is 8.6. That's for 2 movies, Back to the Future and Spirited Away. But for comparing both of them, one came out in 1985, while the other came out in 2001.
Yeah.
So 2001 is the winner.
Okay. So yeah, like you said, we are just trying to the first thing we are using to compare or that we are using to verify our answer to this question is the rating. So we are going to try to check if we can see, we are trying to get the highest rating. And then there's a very good chance we could find 2 movies with the same rating. We want to pick the most recent movie. So we could check when we see like 2 the highest rating, we need to compare which one like came out most recently, and then we could just return the title of that movie. So yeah, who wants to walk me through how they will solve this? Like Python, like speak Python terms.
Okay, first look for empty list.
Okay.
And then return an empty string.
Okay.
First place is And then the way I did it is, so the first edge case is not dead, which means there is at least one movie in the list. So I took the first list's fourth index, which is the rating, and then I initialize a candidate variable, which takes the list entirely, and then I went through the remaining movies from index 1 to the last index, and then comparing and updating all those indexes.
So yeah, the first thing you want to do is handle this edge case. You want to handle the edge case because for the most part of this, we'll be trying to index into our to-do lists. And then if we don't handle the edge case, we'll get into an index error. For example, if you try to index maybe movies 0 or movies -1 or anything you want to try to index, the moment our to-do list is empty, then we'll get an index error. So you want to handle that edge case. And then you said we are trying, like you say you pick the first one, right? And then you are going through for movie in movies. If movie 4 is greater than best 4. Now our best is just the first one. So I guess it's similar to what you said. So you first get the first list of the to-do list. And then you can just use that one as like the base case to compare with every other one of them. So first of all, once you have the first one, you want to check. The first thing you want to check is that the rating is greater. So you want to keep updating it based off the rating. The moment you see another list in the to-do list with a rating greater than the initial one you started with or any one you're currently on, then you know that definitely you want to update your best, right? And then that's one situation. Another situation is when you have, like you said, I mean this thing is just already stated in the question. When you have a situation that they have equal rating, you want to update, or you only want to update if that one has like a recent year. And the index where the year stays is at index 1. So you just need to check that, first of all, if this movie has a greater rating, then fine, you just swap it. But then there's another situation when they have equal ratings. Then when they have equal ratings, you want to pick the one with the most recent year. And then we can just do that with this Python comparison, this logical operator. You can just say if the item at index 4, which will be the rating of our current movie that we're on, is equal to the best, that's the highest we already had. And then we also want to check which one came more recently. So we can see in this situation, let me go back. In this situation, by the time when we first pick this, when we pick this first one, we can see that our rating will first be 4.0. And then we move to the next list. Since the rating is greater, we update that this is now our new list. And then we come over here, the rating isn't greater, so we move on according to the code, we just move on. And then when we get here, we can see that they have equal ratings. And then the moment they have equal ratings, we now want to compare their years. And the moment we compare their years, we can just get that one and then return the item at the first index of what we currently have. And the item at first index of every list in the 2D list will always be the title of the movie. So, with this explained, can anyone just maybe, you might have gotten the question, you might not have gotten it, or probably you lost a few marks on this question. Can you just probably walk us through what you did? Yeah, maybe the class can also learn from that too. Or just like talk about, or if you had a different approach to this, can you talk about your thought process? If you had a very different approach to this. Or everyone did this. Okay. I don't know everyone did it, but yeah. Definitely not everyone did it. Okay. So if no one wants to talk about their approach, do you have any questions about how this works? Okay.
So I've initialized max rating to be 0, and every time, and meaning over the movies, and if the fourth column of the movie, the rating is greater than the max rating, we update that.
Yeah. Okay, that's fine. Okay, you still want to talk about it?
Yeah, and I was curious if what's if we could have a negative rating?
No. I mean, have you ever seen a movie with a negative rating? I don't think I have.
Yeah, that's why I use 0.
Yeah, that's fine. You can have a negative rating. I mean, if you check IMDb, Rotten Tomatoes, everywhere, you see like a positive rating, you can have a negative rating. Oh yeah. So imagine you picked. How about could we do it instead of picking the entire list? Could we, like she said, initialize our max rating to be 0 and then look through this and keep updating it? But would there be a problem that we'll face by doing this? Where we only have the max rating, we don't have like the entire list, we just have the max rating.
Sorry?
Yeah. So if we just initialize our max rating and then we decided that we should keep updating it by whatever rating is bigger. So when we get here, we update it to 4, we update it to 8.6, we update it to 7.8. Now since this isn't greater, it's equal to, so we just leave it at 8.6. But then how do we even get the title of the movie? Because we need to get the title of the movie. How can we get the title of the movie? So it's either you go through the 2D list again and then keep checking if the item at index 4 is equal to this rating, and then I'm now trying to get the title. And even after doing that, you also still need to check if there is another one with that same rating again that comes even more recently. So what you just want to do is, the best situation would be to keep track of the lists. Initialize maybe the first list. I think the first list would be the best. Just initialize it with the first list, index 0, and then you can just go through that and keep updating and use this very simple conditionals. I feel like this conditionals is just directly from the question. The question says if it's, you just need to get the max rating. To get the max rating, just keep taking which is greater. And then in a situation where they have equal rating, you just want to pick the more recent one. So yeah. Any other questions? Or just like maybe just anything relating to this question that you just want to say or share. Okay. So I guess we just start from the beginning now. Start from section A.
Yeah, or if there are any sections that people specifically want to go over.
Yeah, or any section you want to go over.
Yeah, whatever.
Or any questions that you were wondering, how did I get this wrong? Yeah.
Maybe like section, I would do section D.
D, yeah.
If no one has an opinion.
Can I do section C as well?
Oh yeah, okay, so section C. Let's do section C. Yeah.
Yeah. I wish I could. Okay. Okay, so let's go through this. So it says select expressions of type X below. So which of these expressions are of type X? So why is it not of type X?
That's what it says.
Separated by comma.
Oh, I didn't know that. Oh yeah. Okay. And why is this of type X?
That's also initializes the same case as a set.
Yeah, so you notice when you want to initialize a set, can you just stop this there? Yeah. So if you notice when you want to initialize a set, because the set kind of has the same, I would say, format as a dictionary, you can see the braces here, the curly braces, just exactly like a dictionary. Since we have the same thing, the only way to initialize a set will be to call the set and do something like this. So it's the same way with the dictionary. You could either initialize your dictionary that way in Python, or you could also do it this way. And then we know for a dictionary must have a key value pair. And then if we notice this is not a key value pair. This is just something like different items. But our B, we have a key value pair. So yeah, that's what's like dictionary. And then yeah, what would be the output of this statement? C2. Anyone wants to answer that? Okay, true. Why? Who said true? Okay, yeah, why?
Because O is the key in dictionary, so that is true. True and true.
Okay, so yeah, generally, as we've said, when you try to use the in operator on a dictionary, Python evaluates it as you are trying to check if this stuff is a key in the dictionary. So we are trying to check if O is in this dictionary. Yeah. Okay, yeah, you could use if O is in this dictionary dot values. Yeah, that would be the best solution. But you could also do if O is in this dictionary dot keys. But I feel like using dot keys is unnecessary because automatically once you use the in operator on a dictionary, it's just checking the keys. So it's not checking the value. So yeah. So this we evaluate to true. You are trying to check if O is in this dictionary and true and true. Evaluate to true. So yeah. So any questions on this? Okay. So yeah. What's the output of this statement? No one wants to answer this. None?
Yes,
Why?
because there's no return anything.
What?
The function does not return anything back.
Okay. So yeah, we have a function called cook ingredients, and then we are saying veggies is equal to ingredients of veg. So we are trying to check. We have this dictionary ing that we're going to try to call this function on. So it says ing is equal to, we have a dictionary with a key called veg, and then a value which is a list of carrots and onion. And then we are trying to call cook on this dictionary. So by the time we call cook, what does this do? First of all, it initializes a variable called veggies, and then we are saying ingredients of veggies, which in this situation will be ing of veg. So it's kind of like we're having ing. Ing will be our ingredients in this situation, and then we are calling the key veg. And then by the time we do this, we end up getting a list, right? We end up getting a list of carrots and onion. But if we notice, I guess the intended, generally, what would you expect? We expect that the intended code of this is to return veggies, right? But they didn't return anything. And once, by default, when you put return, just return on a function, that means you're trying to return none. So yeah, we'll get D, none. So any questions on this? Or if you need like more clarification?
Good.
Okay. I guess we're all good. So on the next exam that I will do, let's say once you get 100, right? Yeah. But yeah, what's the output of this statement? It's error, why?
Because the concatenation does not work with list
Yeah.
Type error.
We're not saying it. Okay, yeah. So imagine this was like a string. Do you think we'd be able to do this list 88 plus a string?
type error. Oh, list as a string?
Yeah.
Oh, we could do that.
Yeah, exactly. Right? So if it was a string, then what do you think will happen by the time we concatenate a list and a string?
It should append to the end of the list.
You think it will append?
Like to a list and string.
Yeah, exactly. So if we have a list and a string and we try to use the plus operator, then it will take every character of that string and put it in the list as a value at the back. So yeah. So if, for example, we try to do a list 88 plus string AB, then we'll be getting a list of 88, comma A, comma B. You see? But then if we try to do that with a number, there's no way that will work. Or an integer. So yeah, we get an So what do you think would be the output of this? So let me show you. Yeah. What will be the output of this statement? What? Say none.
I shows error here.
What?
For the previous one, the like concatenating string with a list. I think it's showing error for me. It's showing error.
String with the lists.
Yeah.
I'll just make that to work. Also.
So like this is
Okay. So what would be C5? I would get back to that. What would C5 be? What's the output of this statement?
Yeah.
Error, sorry. Error. Okay, so why would he give us an error?
Because like if it was like only like C dot append and then the list with the string C in it, then the output would be 2. But like since now C is the return type of like C dot append, then the return type is none. So like length of none that gives an error.
Yeah, exactly. So first of all, we have a dictionary called. So we have a list with an item which is a dictionary called C, and then we are trying to append another list into. We are trying to append another list containing C, containing the letter C into our list C, and then by the time we do that, it will actually work, right? We'll be able to append it, but then we are saving the return value, and those append have a return value in Python. Yeah, append doesn't have a return value. So is there any list operation that has a return value? Yeah, exactly. So if we try to use extend, extend doesn't have a return value, append doesn't have a return value, but usually one that will have a return value is dot pop. And then by the time it gives a return value for dot append, it will be none, right? And there's no way we can find, there's no property length on type none. So yeah, this will just to give an error. So yeah, C6. It says choose all the following that can be used as keys in a dictionary. Okay, so when you give me your answer, try to like explain why you can't use this and why you can't use the other one. So yeah.
You cannot use list because list is mutable.
Yeah.
And string and boolean are immutable. And set, it takes immutable data, but it itself is mutable.
Yeah, exactly. So when we consider a list is a mutable data type because if, for example, I'm sure, I think that was on the last, I don't know if it was on the last, I think it's on this test, yeah, it's on this one. So if you have a list called, let me say, num, a list num, and then you initialize it to have 0, 1, 2, and then I create another variable called bank, and then I said bank is equal to num. I kind of stored num in bank, right? Any operations I carry out on bank will have effects on my initial list num. So that data is it's a mutable data type, and if you really want to perform an operation, then you need to use the dot copy function. So yeah, a list is a mutable data type. The moment you initialize it, you can still change the values in place. A string is a non-mutable data type, so we can use it as a key in a dictionary, A boolean is also a non-mutable data type. We can use it as a key in the dictionary. And a set, and like I said, although a set can't take in mutable data types, a set can't take in a list. It can't take in maybe a dictionary, for example, because dictionary is also a mutable data type. A set can't take in mutable data type, but it itself is a mutable data type. So yeah. We'll check. What about C7? It says which lines of code will remove the key value pair for price from the product dictionary. What different lines of code can you use? So why can't we use remove?
Sorry,
What?
what did you say?
Why can't we use dot remove?
I think we can, right?
Yeah, why?
Insert. Okay. So the thing is, every Python data structure has has its own specific functions to it. So the only two, at least the two data types you can use the dot remove on. You can use dot remove on a list, and you can also use dot remove on a set. So just take note of that. If you try to perform dot remove on a dictionary, it won't work.
Why would they make it difficult? Like, using
I mean, you should ask people who created Python. But yeah, you can use dot remove on a list. Oh, sorry, you can use dot remove on a dictionary. You can only use it on a list and on a set. So you need to take note of that. The dot pop function, you could use it on two data types. You could use it on a list and you could use it on a dictionary as well. And then the delete.
Well, we can use pop on sets too. It just
Yeah, exactly. We could use pop on set too. We could use pop on set, but I mean, it's not really essential. Yeah.
Benjamin, what if we assign a value to the pop function? Like, what does it return? What does it pop out? Does it return both the keys and the values, or does it?
I would expect that to error, because when you put in something, when you give a parameter to your pop function, it is looking for a key that matches that. So if you give it a value, then to check the keys, and if it doesn't match that, it's just
that's not my question. For example, if I'm doing A equals product dot pop and double quote price.
Oh yeah. So are you trying to say what it will return?
Yeah.
Oh yeah. So in this situation, when you say product dot pop price, it's going to. I would expect it to pop like the entire thing, like everything. Like
Okay. So is the return value just 1200, or is the return value price?
it should be price 1 2. I was expecting price 1 2.
Is there any way that we could use the option D to like remove?
No. Nah. You can't say product of price is equal to none. That means you're just changing the value of price to none. You're not removing. It's still in the dictionary. Yeah.
The key is there, but value.
Yeah, the key is there, but the value is just not. That's yeah. So any questions on this? Okay, so let's check now. It says which of these is a valid and logically correct Python dictionary. So I think a lot of people a lot of people made mistakes on this, but yeah. So what do you think? Which of these is valid and logically correct dictionary?
A and B.
A and B. Okay. Why can't it be C?
Because the key is used on B.
Yeah, exactly. The key is a list and this can't be used as a key in a dictionary. And why can't it be G?
There's multiple keys, yeah. Keys should be unique.
Exactly. So the moment you create, for example, you have an empty dictionary and then you say dictionary of fruit is equal to apple, and then you come over again and say dictionary of fruit is equal to pear. What do you think? What will be the length of the dictionary? It will still be 1 because you just reassigned the value of fruit. So yeah, D is logically incorrect. And C, you can't use a list as your key in Python.
But if it was a set, it would not error, right?
What?
If it was a set, it would not error. It would just take one fruit.
Do you think you can have this in a set?
I mean, without the value, just the keys.
Oh yeah. Okay, if you put, you're saying if you have a set and you put fruit, comma fruit.
Yeah.
Okay, what after that operation, what do you think your set will be?
It'll just be fruit.
Yeah, so it doesn't. Yeah, it's fine. So let's check D. Let's go through D. So yeah, what do you think would be the answer to this?
I thought
1357
Yeah. So I know this could be confusing because a lot of people will just put 1, 2, 3, 3, 5, 5, 7, 7. But you need to know that the operation odd norms plus prime norms wasn't saved in any variable, and then we are not trying to print that variable. So it says odd norms is 1, 3, 5, 7, 9, 11. Prime norms is 2, 3, 5, 7, 11. Then it says odd norms plus prime norms. This operation isn't saved in any variable, so we kind of lose the operation.
why
Right?
would it not error?
Yeah, I think error. Yeah, like, like okay, it's just like for example, if you try to perform
Or you just call it.
okay, you're familiar with dot upper, right?
What?
Dot upper.
Yeah.
When you're trying to change something to uppercase, right? So if you're just trying to do something like, let me say, for I in this, or let me say, if this is in maybe a variable word dot upper, you're saying a variable word dot upper. Why do you think a variable word dot upper doesn't, like, with the word dot upper there, you're not saving it in any, like, you're not saving it in anything. So why does it take error? Like, that's to tell you that operations that return things, you can perform it without even saving it somewhere. It's just that you won't be able to like keep that value. Anything that returns something, you can perform it without actually saving it, but it won't, like, you lose the value. That's what they call. So in this situation, we have odd underscore norms plus prime underscore norms. This operation is carried out, but we don't save what we get from this, and then we print odd norms. Odd norms still remains our initial value. So yeah, it should be 1, 3, 5, 7, 9, 11. So yeah, this, like, this question, I think like a lot of people didn't get this right. And yeah, like, what do you think would be the answer to this? Let me try.
Error.
Yeah. Oh, no. Where? Okay, so if we look at this, we have a 2D list, right? And then in the 2D list, we have, each list contains different data types. We have a string, we have an integer, we have a list, probably, and then it says for song in songs. So this is looping through every item in the 2D list, which every item is a list, right? And then we are saying for info in song. That means we are also going through every item of each list in the 2D list. Then we are saying if R is in info. Now we're trying to check if the string character, or like, sorry, I said string character, if the character R is in info, where info is every item of the items in the list. So first of all, what this will do is it will check if R is in Beyonce, and then it will find R, which is fine. You can check if a string, if a character is in a string. And then we could also check, when we move to 43, do you think it's correct to say if R is in 43? So yeah, you can't use the in operator on an integer. It will give you an error. Because it will try to check if R is in the integer, and there is no way you can find a string in an integer. So yeah, the answer to this should be error, but I know. Yeah. So let's see this. So we have set 1 is Fisk, different variations of Fisk. Set 2, we have is, F, and then Fisk. And then, yeah, it says set 4 is set 1 intersection set 2. So we have, what does it mean by set 1? What do they mean by set 1 intersection set 2? Yeah, so we are trying to check what is in set 1 that is also in set 2. So what do you think this intersection will give us? Yeah, exactly. All lowercase. We'll get physical lowercase as a setting.
The other question, can you use in operators for integers? Like if the
Character or those things.
No, you can't. Yeah, so the in operator can only be used on, for example, if you're trying to check something, if something is in a list, or if something is in a string, or if something, because if you notice, the integer is like 1, it's just because you can you check